Okay, quiz review. Number 4, last one. Austin deposited money into an account with a certain annual interest rate. He was so interested in the amount of money that his account would earn that he checked the balance at the end of every year. After 2 years, his account was up to $5,591.38, and after 8 years, his account had a total of $6,754.56. So, 4 different things we have to do here. Find an exponential equation to model the data, find out what the interest rate is, find out how much he originally deposited, and then when can we expect to see the amount double. So, exponential equation tells you right off the bat that we're going to probably need point ratio form since they didn't give us any starting amount or an interest rate or anything like that. They just gave us 2 benchmarks throughout the years of Austin's account. So, after 2 years, we had the $5,591, and after 8 years, $6,754. So let's go ahead and use those 2 points to start out. So A, 2, and 5,591.38, and 8, and 6,754.56. So if this is my x1, y1, x2, or just x and y. I guess I don't really need the 2's. I'm not doing slope. So let's just go back and do x and y. And we use the equation, the point slope form equation, just to remind you, y1 times b, x minus x1 power. So we plug in what we have here. So 6, well, it's not a 6, 6, 7, 5, 4.56 equals 5,591.38 times b is what I'm looking for, and then I have 8 minus 2. So we divide both sides here by the 5,591.38. Okay, that cancels. Let's bring this up over this way a little bit. So this becomes 1.20803 equals b to the 6th power. We get rid of that exponent of a 6 by multiplying by 1 over 6. 1 over 6. Running out of space. By 1 over 6. I went to the bigger iPad and I'm still running out of room. Okay, so this is gone. 1.20803 to the 1 over 6 power tells me that b is equal to 1.032. Okay, so I have found my ratio. I'm going to make a note of that over here. Ratio equals 1.032. Now I'm going to go down here and erase all this. If you need to rewind, pause, you know the drill by now. Go back and go ahead and do that. Okay, so did I answer the question? No. Find an exponential equation. So all I did was find a ratio, but now I use that ratio and one of my points to write the equation. So A, we get y equals, doesn't matter which one, I'm going to stick with the first point. So I'm going to have $55.91.38 times B, which is my ratio, so now 1.032 to the x minus 2 power. If I had chosen to use the 6,754, then my exponent would be x minus 8. Either one will work and give you the same exact answers for the rest of the problems. So there's my equation for A. B, what is the interest rate for Austin's account? Well, the interest rate we have to find, just like when we find a decay rate, we have to figure out how far away it is from 1. Decay rate is below 1 for the ratio, and for a ratio of something increasing, it's above 1. But how much above 1 in this case? So B, we would say we have 1.032 minus the 1 whole, or the 100%. Leaves us with 0.032, and converting that to a percent is 3.2%. So for B, the interest rate for Austin's account is 3.2%. I'll just put that in here, 3.2%. That way I can erase and get some more room to do parts C and D. So far, so good. All right, let me erase B, and we'll move right on to C and D. Maybe this will be the shortest one yet. All right, let's see. Purple. I don't think I've used purple yet. Okay. How much money did Austin originally deposit in his bank account? So we did this in number 1. We're talking about originally depositing, or an initial amount of something. Remember, that's when no years have passed, so our x value is going to be 0. So I'm just going to plug 0 into this equation we wrote in A. Y equals 5,591.38 times 1.032, and then 0 minus 2 power. When we calculate that, we get an original deposit of $5,250, and that's just from calculating this using a calculator. $5,250. So Austin's original deposit that he put in the bank, $5,250. All right, and D. In what year can Austin expect to see his original deposit double? Okay, so much like, again, back in number 1, this is a guess and check type problem right now. We will be learning in the next couple of investigations how to actually solve these, but right now it's still guess and check. Again, I would say let's put this equation into your calculator, scroll up and down your table until you find out when the amount in his account will double. Let's do a little bit of legwork first so that we know what we're looking for. His original deposit, $5,250. So let me just make a note of that. $5,250. So when can his original deposit double? So we're looking for D, when will his money be? So when Y equals $10,500, when will that happen? So again, the equation, we can write 10,500 equals 5,591.38 times 1.032 to the x minus 2 power. And we could sit with the calculator and guess and check and plug in numbers for x until we get as close to 10,500 as we can. We could keep trying and keep trying and keep trying and keep trying, or we can throw it in the calculator into a graph, Control T, split screen the table, and scroll through our table. Let's let the technology work for us since we're allowed to use it in these types of situations. So go ahead and do that, scrolling down, and you find out 22 years, Austin's money, he will have $10,498.20. That's pretty close to $10,500. So I would say his money would double a little after 22 years. All right? Hopefully you've studied, hopefully you've taken some good notes, hopefully you've actually done most of these problems on your own first, and this is just helping you get through some rough spots or validating what you've already done. And you're come prepared for the test, or the quiz rather, on either Tuesday or Wednesday. Remember, SAP on Monday if you need it, and I will see you next week.